Hi, welcome back to another episode of Algebra and Words, the video series for YouTube. In this video, we're going to continue our discussion on polynomials, and we're going to take a step further after factoring polynomials into solving polynomials, with a specific focus in this video on solving quadratic equations that come in various forms. So I have a number of problems on the board, which I'll explain in a second. But I wanted to remind you that if you prefer to follow along with what we're going to go over in this video in written form, if you'd like to sort of read along with it and have another visual, you could pick up my book Algebra and Words, and everything we're about to discuss starts on page 86 of Algebra and Words. The link to that on Amazon is in the description box below. So anyway, let's get started. In this video, we're going to look at the 3 or 4 main types or ways or forms that quadratic equations can come in. They can come in a variety of forms, but they all sort of fit really one of these 4 variations. Alright, and it's very important that you take a sort of special look at each one, because each one sort of has its own special method of solving. If you kind of go at it freestyle, unless you're using the quadratic formula, which you can apply to any quadratic equation, but you want to be able to identify each type of variation so that when you get to a test, you know which method to use to solve. Otherwise, you might sort of get confused and sort of go down a path of nowhere. So I'm going to explain all the details involved. What I have on the board is, and I know it's a little cluttered, but what I have at the top is ax squared plus bx plus c equals 0. That's the standard form, sort of the generic standard form of a quadratic equation. And real quick, how do we know it's quadratic? Quadratics are always defined by having the highest power of variable raised to the power of 2. Whenever the leading term in descending order is x squared, you know it's a quadratic, and a quadratic, when graphed, becomes a parabola. But that's a separate issue and topic for another video. But anyway, this standard form kind of shows all of the terms with all of the possible numbers involved. Coefficient A, coefficient B, and constant C. Now, you might get a problem that has all of these terms with numbers for each. However, and I cover that more specifically just in factoring trinomials in another video. So you can watch that video for that. However, in this video, we're going to focus on what happens when C is 0. That would look something like this, and I have a problem which we'll factor. Also, what happens when B is 0 and it's missing? Could look like this or this. And also, what about when B and C are 0 and they're missing, and it might look something like that? So I'm going to show you how to identify them, and then also the strategy to use, and then we'll factor it and see how it comes out. Now, let's start with the top one. And we have x squared plus 3x plus 2 equals 0. I would call that a trinomial that has all 3 terms. Before we factor that, I just want to point out that it could come in this form, but it might also come like in sort of a mixed form, not exactly standard form. And for example, it could come like this: x squared equals negative 3x minus 2. When you have a quadratic and a trinomial that has all 3 terms, but they're not in standard form, it's a good idea to move everything to the same side as the x squared, the side that the x squared terms originates from. So that would be over here. Move the negative 3x minus 2x to the left by adding 3x plus 2x to both sides, and then it would become in this form. Okay, a quick little side note about that is, I said to move everything to the side that the leading term of x squared originates, and there's a reason for that. It has to do with the direction of the parabola of the resulting graph. If you happen to move this x squared to the other side and it became negative, basically it would change the direction of the parabola than what it's originally meant to be. I go over the graphing in another separate video later. But in summary, move all the terms to the same side so that it's in standard form like this. Alright, and I'm going to erase these so we have a little room to work. So since this is a 3-term trinomial quadratic, we're going to factor it, and then we're going to set each factor equal to 0 and solve. So if we factor this, it's a fairly simple one. We could factor it as x plus 2 times the quantity x plus 1 equals 0. And we don't have much room, so over here we're just going to set x plus 2 equal to 0 and x plus 1 equal to 0, and then we'll separately solve them. Minus 2, x equals negative 2. And for the other one, minus 1, x equals negative 1. So we just took the original trinomial with 3 terms, factored it into 2 binomials, set each binomial equal to 0, and solved, and we got x equals negative 2 and negative 1 for this problem. So I'm going to erase that so we have a little more room to work, and then we'll look at the next one. So I just wrote the answers up here if you want to look back and see them all together. Alright, now let's come down to the next one. And the next one represents a quadratic where we might have ax squared plus bx, where c is 0. And when c is 0, it's missing. It's just not there. And so I say that here, when c is 0. And I wrote a problem of what it'll actually look like. It could look like this. There's no space like I have, but it'll just look like this: 10x squared plus 15x equals 0. You could also see it in this form. 10x squared is equal to negative 15x, meaning the bx term is kind of on the other side of the equal sign. And similar, if you remember what we did in the last problem, when you have 2 terms like this, you want to shift all the terms onto one side for the reason you're going to see in the next step where we're going to start to solve. So it could come like this, but to get it into this form, add 15x to both sides to move all terms to the left, and then it should be in this form. And once it's in that form, the strategy that you're going to use for a polynomial like this when c is 0 is to always look for a greatest common factor. Now in this case, the greatest common factor is 5x. Alright, but I just want to point out, there won't always be a coefficient as part of the greatest common factor. Hypothetically, if this was 2x squared plus 3x, then the only greatest common factor would be x. But in this case, it happens to be 5x, so we factor that out. And I'm just going to erase this for more room. But now we're going to factor the 5x out, and it's going to look like this. 5x, and then in parentheses, whatever's left after we divide out 5x from each term. And that's going to leave us with 2x plus 3 equals 0. Now, again, we factored a greatest common factor out. We had both terms on the same side. Now we have it like this. And whenever you see it factored like this, your first term will always result in x equals 0. And if you want to check that, that's because we're going to take each factor and set each factor equal to 0. So 5x is a factor, and if you set it equal to 0 and wanted to isolate x, you would divide both sides by coefficient 5, and 0 divided by almost any number with the exception of 0. 0 divided by 5 becomes 0, so 5's cancel to 1, so this x would be x equals 0. And we always know that this first factor will result in x equals 0, whether there's a coefficient or not. And the last step we need to do for that problem is to now take this group, the 2x plus 3, and set it equal to 0 and solve for x. So we're going to subtract 3 from both sides. We're going to get 2x is equal to negative 3. And now we're going to divide both sides by coefficient 2. And when we cancel out the 2's on the left, we're left with x equals negative 3/2. So the answer to this original problem is x equals 0 and x equals negative 3/2. Alright, so let me erase that for more room, and then we'll look at the next one. Okay, let's look at the next one. This one we have where b is 0 and the middle term is missing. So it could resemble a problem that looks like this. 2x squared minus 50. Or it could also come like this. 2x squared equals 50. Alright, I'm going to save this one to do last because I'm going to do this one. It's pretty easy, but I'm going to save this one for last because there's kind of two ways to do it and I want to show both ways. So we'll come back to this. Let's look at this one. And this is one where both b and c are 0. So we only have the ax squared term, and it might look something like this. And this one is easy because we automatically know that since b is 0 and c is 0, that our x values are going to automatically equal 0. But if we want to just go through all the proper steps and check that, we would divide both sides by coefficient 7. The 7's cancel to 1, leaving x squared. And 0 divided by 7 is 0. So we write 0, and then we'll take the square root of both sides. The square root of x squared is x, and the square root of 0 is just 0. So a problem like this, and any problem where both the b and the c terms are 0 or missing, is going to result in x equals 0, and that's pretty much it. So let me erase that, and now we'll come back to these two problems that I promised a second ago. Alright, and let's take this now below, and I should probably erase this so it doesn't get confusing. Alright, now the last type we're going to look at is when the b term is 0 and is essentially missing. And it could look like this. 2x squared minus 50 equals 0. Or it could come where both terms are on opposite sides. You can actually do this either way, and it's kind of up to your preference as long as you do it the right way. Let's start with this way. And if you remember from previous videos where we identified polynomials, this is the difference of two. Here's what we're going to do first. We're going to look for a greatest common factor, which is 2, and factor that out. That would become 2 times the quantity x squared minus 25 equals 0. And now let's divide both sides by the coefficient 2, which basically gets rid of it. This becomes 1 and goes away, and the 0 divided by 2 still makes 0 on the right. So just for room, I'm going to erase this because we know that it just kind of simplifies down to x squared minus 25, which is why I chose the problem. One is to remind us to check for greatest common factor, and secondly because now, I almost said it a minute ago, but now we have an actual difference of two perfect squares. And if you remember how to factor the difference of two perfect squares, factors into conjugate binomials. So we could say x minus 5 times x plus 5 equals 0. And if we set each factor equal to 0, then we would get x minus 5 equals 0. Add 5 to both sides, and we get x equals 5 on the left. And then same with this, but the signs will be opposite. X plus 5 equals 0. Subtract 5 from both sides, and x equals negative 5. And our answers for this original problem would be x equals positive 5 and negative 5. But I told you that there's two ways that you could solve this, so let's look at the other way. Let's suppose that the problem were given like this. Again, let's try to reduce as much as possible by dividing both sides by coefficient 2. And in this case, you could look at it as you're trying to isolate the x squared. So So I'll just erase this to make division signs. We'll divide both terms by coefficient 2, which cancels that to 1 and reduces 50 over 2 to 25. So we get x squared equals 25. Now, if you happen to leave it in this form, that's fine as well, because you're almost done solving. Take the square root of both sides in this case. On the left, square root of x squared is x. But what is the square root of 25, or of any positive perfect square? Always remember that the answer is going to be plus or minus the square root of it. So the square root of 25 is plus or minus 5. And why is that? Because, think about it, positive 5 squared equals positive 25. But also, negative 5 squared also equals positive 25. That's why you must put both the positive and the negative form of that square root. Let's compare this to our answers from the other method that we used of factoring into conjugate binomials. And notice they're the same. This we have positive and negative 5, and this we have positive and negative 5. So that just goes to show that both forms result in the same answers. Normally when we have a plus or minus, you can write the answer like this, just kind of consolidated as one, but it really does mean that we have both answers, positive 5 and negative 5. Let's summarize all that we did in this video, since it was kind of a mix. In the first one, we had an example where we had a quadratic trinomial where we had all three terms. And all we did was factor them into two binomials, kind of in the traditional trial and error method form, set each factor equal to 0, and solved, and we got x equals negative 2 and x equals negative 1. The next one is where we had a missing c term, or when c is 0. When we have a missing c term, it looks like this form, where we have the first term with x squared and the next term with x, but no c term. The best thing to do in that case is to move all terms on one side, look for a greatest common factor, which will always include x, but may not always include a coefficient. Factor the greatest common factor out, divide, and you can divide both sides by the coefficient. We didn't do it here, but we didn't really have to. We set this factor, the greatest common factor, equal to 0 and solved. And in a problem like this, one of your answers will always be x equals 0. You'll also always have another binomial factor, set that equal to 0 and solve. And in this case, that solved out to be negative 3/2. So we had x equals 0 and negative 3/2 for this type of problem. Then in the next one, we had a problem where the b term is 0 or missing. And it could look like this. It could look like the difference of two squares. It might also come as a perfect square, or something that's almost a perfect square equal to another number on the other side. And there's two ways to solve it. If you leave it as the difference of two squares, you can factor it into conjugate binomials, set each binomial factor equal to 0, and solve for x, and you'll get two answers. Or if you leave it in this form, divide both sides by any coefficients in front of x squared, if there are any. Isolate the x squared equal to whatever it equals on the right. Take the square root of both sides, and remember that when you take the square root of both sides, you get the positive and negative of the square root of that number. Also, the one that I erased is when you have when the b term and the c term are 0, and you only have something like ax squared equals to 0, and in that case, automatically you could say x equals 0. So that concludes this video. I will be looking at some other problems in other videos where we kind of do some more mixed practice, and so that's what you can find in other videos. Thanks for watching. I really hope you found this helpful, because these are some details that really need to be looked at and are often not discussed enough with students. So I hope that you found the algebra and words factor helpful here. If you did, please give a thumbs up, please share with your friends, please leave any feedback in the comments section, and you'll also find links in the comments section. Please subscribe to the channel, hit the bell so you can be alerted when new videos come out, and also check out other content on Facebook and Instagram, and I'll see you in the next video.